So today we're looking at processing specimens for acid-fast culture. And specimens that you get for acid-fast are kind of categorized into two sections: sterile specimens and non-sterile specimens. The sterile specimens can be directly inoculated into your media. The non-sterile specimens have to be processed first through digestion and decontamination to get all the normal flora out of them. Because acid-fast bacteria do take a while to grow, so we do not want them to overgrow with any normal flora that might be in the specimen. So we do this by using N-acetyl L-cysteine. There are packs out there that come from manufacturers that's already made. This is a reagent pack where a powder is poured into the buffer, and it's good for 72 hours, so you do have to look at that. When the specimens are processed, we will make 2 slides so that one of them can be read by fluorescent method, and then if it's positive or questionable, they can follow up with a Kinyan method. Culture for AFB, it's recommended to use 2 different types of media. One that will grow everything and another that has antibiotics in it to help inhibit some things. Culture is 8 weeks, so we generally use slants in tubes so that the media does not dry out so quickly, and because it saves space versus plates stacking on top of each other. It's also recommended that you use a liquid media. This fits in the Bacti-Alert's blood culture instrument, and what the liquid media will do is actually enhance the growth of the organism, where if you had a tuberculosis, for example, it would take 8 weeks to grow. In here, it'll grow in about 4 to 5 weeks, and you can get identification quicker. So we're going to process these specimens and go through the entire steps from beginning to end. It'll be in a couple short segments because there's some incubation times and centrifugation times in the middle, so we will pause during that. So the first step is to take your patient specimen in a 50 ml conical tube. You want to have no more than about 5 mils of specimen in there. If you have more than that, you're not going to get the digestion and decontamination done effectively. So we open that up. We pour equal amounts of the N-acetyl L-cysteine, making sure that we do not touch the tube with our bottle because we don't want to cross-contaminate anything. Everything for AFB culture should be done within a Class 2 biological safety cabinet, of course, because you don't know when you are vortexing and opening things if you're going to create any aerosols, and we don't want to breathe any of that in. After we have put equal amounts of the N-acetyl L-cysteine in here, we are going to vortex them really well, because if there is any mucus in the specimens, we want that to break apart. The purpose of the N-acetyl L-cysteine is to not only break apart any mucus strands that are in the specimen, but also to help kill any normal bacteria that are in there. After this is vortexed, we're going to let it sit for 15 to 20 minutes. Generally, you set a timer for 15. That way, if you're a minute or 2 late, you're okay. If you set it for 20 and go too long, the N-acetyl L-cysteine could actually start killing the AFB bacteria, and we don't want that to happen. So we'll set our timer for 15 minutes. So the specimens have sat for 15 minutes with the N-acetyl L-cysteine in them for the decontamination process, and we want to stop that from happening anymore because we don't want to kill our AFB bacteria. So you actually put in a buffer solution that neutralizes the NALC setup. You're going to pour this in until it turns clear because the NALC is normally pink. With this specimen, for example, there was a lot of blood in it, so you can't tell that it's clear or not. So we just fill it up about to the top to make sure. But this sample, for example, is showing pink. So we will put the buffer in until it turns clear, at least, which is generally filling it all the way to the top with a 50 ml tube with at least 5 mils of specimen in it. So it has now turned clear. We know that it is neutralizing the nalk. We'll give it a nice little mix real quick just to make sure it spreads through. And then we're going to actually centrifuge these. And what we're going to do is centrifuge them for 20 minutes at 1500 G. And when they come out, we will actually have a pellet in the bottom. The pellet will be resuspended after the supernatant is poured off, and we will use that for setting up our cultures. So we are going to put these in holders for our centrifuge, making sure that we're balancing everything correctly. So since we have 3 patients, we have 1 just water balanced tube in there. And the other thing that you have to have for safety reasons, being AFB cultures, you need to put safety caps on your, why does this not fit? There must be other ones. Oh, it's these. Helps if you make sure you have the right inserts before you're trying to centrifuge, because these ones are too tall and the lids don't fit. There we go. So then we put our safety lids on that lock. Why are these not fitting? Why are these not? Oh. Because they go down further. Yeah. Helps if you know the equipment you're working with. There we go. There we go. So the lids lock on to make sure that if anything were to happen during centrifugation, if they were to fall apart, if the tubes were to break, everything stays contained within this setup. Okay, so our specimens are done centrifuging, and now we're going to actually inoculate our media and our slides. The first thing we need to do is put a little bit of the antibiotic supplement into our bottles for the liquid media. So like with anything, we always want to clean the surface of our bottles. And because of the type of bottles they are, we're actually going to have to use a needle to transfer everything. So we pull out a 1/2 ml of the antibiotic supplement. And you have to pull slowly with these kind of needles or else you're going to get a lot of air. And then transfer that into the bottle. We're going to do that for each liquid media. Since this does not have patient specimen in it, I can use the same needle from one bottle to the next. Always making sure that you're careful and don't stick yourself, because that's the last thing you need. An exposure incident. And these have safety needles to them, so we hit the little button and the needle retracts. Going into the sharps container either way because it is sharps waste. So looking at our specimens now, you can see that there is a button at the bottom where it's been centrifuged. So what we're going to do is actually just carefully pour off all of the liquid, so all we have left is that button at the bottom. This patient has a little bit of sludge at the top, so let's grab a swab and get rid of that as well, because that's kind of gross. We don't want to add this to our cultures. And then we have a reconstitution buffer. It's just a PBS. These come in little 3 ml bottles. I'm going to pour one of those into the specimen. Put our lid back on. And vortex to mix. So now our specimen has been reconstituted pretty well. And that's what we're going to use to inoculate our media. So the liquid bottles have to have a needle to insert the specimen. So we have to be very careful with those. Putting our needle in here, trying not to contaminate ourselves in the process. Pulling up a 1/2 ml. I don't even think I got any. I didn't put it down far enough. Let's get that in there a little further. There we go. Pull up a 1/2 ml of our specimen and put that into the bottle. So our liquid media is now inoculated, and that can go into the blood culture instrument. The other thing we have to do is inoculate our slides and our solid media. So for safety purposes, we're just using a disposable sterile pipette for that. For each media, we're going to add 2 to 3 drops. For AFB cultures, when you put your lid on, you leave it loose for the first week, and after you look at it for growth that first week, then you can tighten the lid. And then we're also going to put 2 drops or so on each of our slides so that they can start drying. The slides have to sit on a slide warmer at 70 degrees Celsius for a minimum of 2 hours before you can stain them. So I'm going to do that with these other 2 specimens, and then we will be ready to put everything away for incubation. Okay, so now that all 3 specimens have been taken care of, our liquid media will go on our blood culture instrument, and that will take care of determining when it's positive. So if bottles do come off positive, they will have slides made of them to see if there's any growth, and if there is, will be carried on for identification. Our solid media will go in a 37-degree incubator with CO2 for up to 8 weeks, being looked at weekly for growth. If growth does occur, slides will be made to see if it is AFB or not, and then identification to follow if they are. These slides, after sitting for 2 hours, one will be stained by fluorescent method to screen with. If it's positive, confirmation will occur with Kenyan stain. The remaining specimen is generally put in the refrigerator and kept for a week in case additional testing needs to be performed. For example, if somebody's slides were positive today with AFB, this can be sent out to a reference lab and DNA probe testing be performed to determine if it's Mycobacterium tuberculosis or not. So this is the end of the AFB processing. Everything's going to get put away and incubated appropriately, and that is all. Bacterium tuberculosis or not. So this is the end of the AFB processing. Everything's going to get put away and incubated appropriately, and that is all.